Good evening, students. Am I audible and visible to all of you?
Yes, ma'am.
Okay. So one by one, first of all, can Ananya tell me which chapter you are being taught in your school?
Mom, I think we finished the first four chapters. And we're doing the first chapter now. We finished the other three chapters.
You have done chemical bonding?
Yes, ma'am.
Okay. So do you find anything difficult? Like is VSCPR and all the theories clear to you?
Yes, ma'am. That is clear.
Okay. What about you, Shweta?
Now the same thing, ma'am.
Uh, please be a bit louder. I cannot hear you, Shweta.
We are from the same school, so we
Okay.
have like finished everything.
Okay. Okay. At the end of the class, I will want to know ki, do you get something extra to understand from us? Like in the previous class, we talked about the Lewis structures. We discussed odd electron, or are they going into that detail in your school? Can Ananya put some light on that?
Mom, actually in our school they didn't teach us the different types of bonds. They only taught covalent bond and ionic bond. So they didn't teach polar, covalent bond and those type of bonds.
And what
They
about the
didn't
Lewis dot is okay? Lewis dot structure and
that
some.
they
Okay,
taught that.
okay. So let's talk about let's move forward. We will today spend some time with the ionic bond. This is very clear that ionic bonds are formed by complete transfer of electrons, right? Between sodium and chloride, you must have seen it multiple times. Even I have taught you multiple times. Now, my question is, if now we are now talking about what type of a questions you get or what type of a knowledge you should get is, okay, what do you expect from the qualities of the atoms? That means loss of electron is measured in terms of, what do we call this? We have done it in periodic classification. Loss of electron is measured as, Ananya, Shweta, anybody?
Mom, can you repeat?
See, in periodic classification, we studied about certain properties, right? Electron gain enthalpy, electronegativity, ionization enthalpy, metallic character, and so on. My question is, which property determines the loss of electron? Whether it will take easily, whether it will take with difficulty. Can you name that property which is used to find out the capability of an atom to give out the electron? What was ionization enthalpy, Shweta? And what was electron gain enthalpy? Did you get my question, Ananya?
Yes, ma'am.
Okay. So, which type of elements are supposed to form the ionic compound? That is the question. As I told you, we are saying, or we are learning how sodium chloride is formed in since class 10th, I believe, right? But when we move to class 11th, we move towards competition. Now, this particular topic which is just a paragraph in your book, is very important that if somebody says you, write the characteristics of an element which can be used for the formation of ionic or covalent bond, or which shows the formation of electrovalent bond. So I'll explain it to you, and then I'll ask you to explain it the same to me. See, we say loss of electrons is ionization. That means one of the processes which is taking place during the ionic or electrovalent bond formation is transfer of electron or loss of electron. So that means if it can be done easily, that will be better. So ionization enthalpy of an element should be, or rather the element forming cation should be low. Is it clear to Ananya and Shweta?
Yes, ma'am.
Okay. Now then on the same basis, now the question is clear to both of you. Now what about the electron gain enthalpy? Should it be high or more? Think logically and
Ma'am,
please
it's low. Is it low?
No, if you are answering, then give me a logic.
Ma'am, I'm sorry. It will be high because it will if it gains more electron, then it can be more stable.
Yeah, very correct, Ananya. That anion forming atom to have high electron affinity. Right? By this, we mean to say that the question can be framed in a different way also. What is the ease of formation of ionic bond? We must say the first point, the atom or the element which is forming cation should have low ionization enthalpy so that it can give out the electron easily. Number two, an ion which is forming the element or the atom forming the anion should have high electron affinity so that it can accept the electron very easily, right? Now we use crystal lattice. Now what is a crystal lattice? Please remember that ionic compounds do not exist as a discrete molecule. Like you can never find a molecule of sodium chloride in isolation, right? This molecule is never available. They exist in the form of large crystals. Now, what are these crystals, or what is a crystal? Please remember that crystal always have they have a definite shape, like hexagon, pentagon, rhombus, cube. These are the different shapes, right? So crystal means it has a definite structure. Now, what is lattice? For lattice, I was looking for, or you can just imagine that you have those dices with which you play Ludo or any other board game, right? Here, if you look at the image carefully, you can see this is one dice and above it is another dice. Next to it, I'll say this is one dice. This one is the second dice. This is the third dice. This one is the fourth dice, right? Dice means here I mean to say cube. So if you can understand the fact that cubes, if they are placed in all direction, front, back, top, bottom, what they will form? Lattice. Lattice is arrangement of atoms in three-dimensional space, right? In this case, this is the structure of sodium chloride. Pink and yellow ball represent sodium and chloride ions as shown here. The pink color is chloride and yellow colored is sodium. Is it clear now to both of you? What is a crystal lattice? Because you will be using this term very often. Not in this chapter, but many other chapters.
Can you tell the definition of crystal lattice once more?
Crystal lattice is a specific geometrical shape. Crystal lattice can be defined as a specific geometrical shape formed by repetition of unit cells. Repetition of unit cells in all directions in three-dimension space. Repeat unit cells in 3D space. As you can see, you have a cube, which is a unit cell. I'm just putting it in a bracket. In this case, it is a cube. It can be, as I told you, it can be rhombus, it can be octahedral, it can be anything. Is it clear, Shweta and Ananya, that what is a crystal lattice?
Yes, ma'am.
Okay, there used to be a chapter in class 12 named as solid state. It was pretty difficult to understand because you have to have a 3D imagination and vision for it, right? So, because of this crystal lattice, there is a certain energy which is attached to it, and that is called as lattice energy. The definition of lattice energy can be asked in the examination, right? So what will we say? As I believe you are clear about that energy and enthalpy can be used as a synonym. Enthalpy is a better term, although roughly it means the same thing, right? So how do we define lattice enthalpy or lattice energy? That amount of energy which is required to completely separate 1 mole of solid ionic compound into gaseous constituent. Right? Now, look carefully at the screen. You can see, look at any yellow ball which is placed at center. Now you can see it is surrounded by many yellow balls as well as the pink balls. It is not that one sodium ion is to be attracted by only one chloride ion. Let's say if I talk about, take any one. If I talk about, let's say, this chloride ion, right? This chloride ion will be attracted by this sodium, this sodium, this sodium, this sodium, even this sodium. So, had it been alone, right, it would have been attracted only by 2 or 1 cation or anion. But in this case, in case of a lattice, it is attracted by many other ions. Therefore, solids are highly stable, right? When we do some numericals in the later half of the chapters, not this one, but say something like thermodynamics, then we may come across that lattice energy of formation of sodium chloride is X and that of magnesium chloride is Y, which is more stable and Y. So for that purpose, we must remember that what is in lattice enthalpy, right? Now, We will now understand what is VSEPR. As both of you have already studied, can Ananya throw some light? What do you understand by VSEPR? Because to me, we have to understand why we require it at all first at the first place. Can you tell me?
One second, ma'am.
Okay. Shweta, do you have any idea? Why do we use VSEPR? What is its use?
Is it to like maintain the shape of the atom?
Did you say the first word as maintain?
Yeah.
Okay. See, we will be using this, say, as you have, yeah, Ananya, I'm waiting. Please say.
Mom, like when the atoms bond with each other, they form like a specific shape. Um, we find that shape using the VSEPR theory.
Okay, I will correct or I will try to upgrade both of your understanding. Please remember one thing, when you move from class 10 to 11, you're supposed to be more specific. Atoms will combine to form a molecule. They will never, they are never going to form a shape. You have to predict the shape. We say ionic compounds are directionless. Ionic compounds do not have shape. Do you know why? Ionic compounds do not have shape. Again, an interesting question. See, when the electron is lost or gained, the charge is spread over the entire surface, right? Like if you have a ball which is positively charged, what will happen? Every part or every inch or a centimeter square area of that ball will acquire the equal amount of charge, let that be positive or the negative. That means attraction from both the ends will be equal. Like assumingly, these are two balls. This is positively charged and this one is negatively charged. So what will happen? They will attract each other equally in all directions, right? If they were attracting, say, let's say in a left corner more, so molecule will have this type of attraction of a shape. If they are attracting more in this direction, a molecule may have a shape like this. Is it making sense to you, Shweta and Ananya?
Yes.
So what we can be saying, the answer is because they have equal charge distribution on the surface. On surface of atom or ion, right? Now coming to the covalent bond, they are sharing, especially in case of a polar covalent bond. We have seen that at some place the attraction will be more and at some place the attraction will be less. It will give rise to a particular shape. So first of all, and the foremost thing, we must remember that we use VSEPR for predicting the shapes of covalent compounds or covalent molecules. right? Again, name of scientist is of not that use, but the reason why somebody has to develop this theory, because before that, as we have learned, Lewis just told us there will be electrons, but he never shared or threw any light on the shape of the molecules. So what is the use of VSEPR? It is used for predicting the shapes of covalent molecule, as I have already told you. It's used for predicting the shape of the covalent molecules or the compound. And it is based on the repulsive interactions of electron pairs in valence shell of the atoms. I believe it makes sense to both of you. I
Yes,
believe we are
ma'am.
clear what is a bond pair and what is a lone pair
Yes,
of
ma'am.
electron.
Yes, ma'am.
Okay, okay. We believe all of us, both of you know that bond pair and lone pair electron, right?
Yes,
Yes.
ma'am.
Can you show
Okay.
the previous slide for a second?
Any confusion into it?
I'm copying that time.
Okay. Once you are done, please let me know.
Done now.
Okay. See, for VSEPR, we say that it depends on both lone pair and bond pair. It's not that lone pair is not participating in the bond formation, so it doesn't affect it, right? We know that valence shell electrons are bound to repel each other. That's a simple fact. I have to copy it down and explain it to you. Exactly, you will find it written in NCERT, right? Given a choice, I will not prefer to teach. But I have seen school teachers giving you the question, explain the main postulates of VSEPR. So therefore, I also have to put it here that first of all, we need to be clarifying if there is any doubt into it. Then, see, we assume that valence shell, as I keep on telling you every time, we still draw it circular or spherical, but it is actually elliptical in shape, right? Valence shell is spherical. We know that why there is a certain physics into it, right? Because it at maximum distance from one another to minimize the repulsion from each other. Is it clear? You need not copy it. If you wish, I have no issues into it. But every word is given into it. NCERT, we already know all of them. Right? So should I move ahead, Ananya and Shweta?
Yes, ma'am.
Okay. Then we say everybody wants to be in a comfortable position. It's a human nature. Like I'm sitting, you are sitting. We are doing it at our own comfort, finding a best couch or a chair at our home, finding a finding a best position where the voice is clear, the visibility is good, camera angle is proper. So that's the basis of VSEPR, right? They will try to occupy such a position that where the repulsion is minimum, that means stability is maximum. See, if you have 2 points like this, if you put them here, they are going to repel more. But if you put your hands like this, the 2 points are outside. They are at a higher distance from each other, right? So they will repel less. So every electron tries to do such a thing, right? Resonance is something else. We will talk about it later in a separate topic in the same chapter, maybe after this, right? Then multiple bonds are considered as a single electron point, right? This again we will talk about when we are doing sp2, sp3 type of a hybridization. Coming to this point, as you have done it in your own schools, it must be very clear that lone pair repulsion is highest, followed by bond pair, and then lone pair, right? Now, have you thought about this question? Why lone pair repel more? Although I have shown the answer, because again, it is a question which may be asked in the school. Do you understand the meaning of this question as well as answer? Ananya.
Mom, I just know the order. My teacher did not tell like why it is. She just told the order.
Okay. See, I believe both of you understand this fact, right? This must have been clarified by your school teachers. That lone pair repulsion is highest, followed by lone pair, bond pair, followed by bond pair. But the question is why? At the end of the day, both of them are electrons. So why this rule? We say lone pair are localized. Localized means that they will be, see, if I'm drawing ammonia, nitrogen has a lone pair of electrons and it is bonded to 3 hydrogen atoms. Now this lone pair is localized or concentrated at nitrogen atom. Whereas the bond pair electron of nitrogen and hydrogen has a larger area. This electron pair is in fact spread between nitrogen and hydrogen, this much big area. Whereas the lone pair is localized, right? So if I use a term saying it as charge density per unit area, both of them, in both the cases, what do we have? We have 2 electrons. 2 electrons spread over such a small area and 2 electrons spread over a comparatively larger area. They are spread, right? It's something like, unfortunately, maybe a bite, insects bites you. What happens? Your particular hand or a leg, it swells up. After few days, you will see the swelling dissipates. Earlier, it might be at such a small area, then it will spread like this and the pain will subside. Similarly, when the electrons are localized at 1 carbon atom, it is highly concentrated. Its impact of repulsion will be very high. But when it is shared between 2 atoms, that is a bond pair electron, it is spread. So what I can say technically, charge density per unit area is higher in lone pair electrons as compared to bond pair. Is it clear, Shweta?
Yes, ma'am.
Okay. So if I ask you what you will say, why lone pair repulsion is high, what will be your answer, Shweta?
They are like closer to the like, because they are closer to the nucleus compared to the bonding pairs.
No, that's not the answer. I said, see, they are localized. They are concentrated at one place. Please remember, the lone pair of electron in this example of nitrogen is only at nitrogen, right? Its concentration is very high in this area. Whereas the bond pair electron between N and H will be spread over a larger area. So charge, see, that's a technical answer. You said a term, lone pair are more closer to the nucleus. If I remember my structure of atom, what do we say? If this is an orbit, let's say it is a fourth orbit, we say this is the s electron. This one is the p. Similarly followed by d, similarly followed by f. Between s, p, d and f electrons, it is s electron which is closest to the nucleus. So that's something else, Shweta, right? We are talking about the lone pair and bond pair. Lone pair belongs to one person. Bond pair belongs to be shared between two people. Its concentration will be less. Suppose you have one chocolate. If you are eating it alone, that means you are getting a larger area, a larger amount of chocolate. But if you have to share it with Ananya and with me also maybe, so what will happen? Your share will decrease. You will get only 1/3 of it, right? So similarly, bond pair electrons are shared only or placed only in one atom. Therefore, their concentration, which is technically said to be charge density per unit area, is very high. So when something is very high, the concentration is high, they are going to repel at a higher rate. Is it clear, Ananya and Shweta now? Now, Ananya, what will you write in your answer book? That why lone pair of electrons have more repulsion or cause more repulsion?
It's because they're closer to the one city.
Okay. Now,
It's because they're closer to the nucleus.
nucleus of what?
The nucleus of the central atom, like the atom is there in the middle.
Okay. That's also another way of understanding the same thing. No issues in that. Okay. Moving on, can you predict the geometries, or do you remember that chart which you might have been taught in the class? If I tell you to predict the geometries or the shapes of, let's say, if I want you to predict the shape of BeH2, BF3, methane, water, before water I want ammonia, water, then PCl5 and SF6. Beginning with BeH2, can you predict its geometry or shape? I'm giving you half a minute or a minute, please.
Shape for all three or just BeH2?
I didn't get you. Please say again.
Mom, should we find the shape for all seven or just
No,
the first one?
find it for BeH2 only first.
Okay.
There is some network issue. I have just stopped my video and the content for the time being.
It will be a linear pair.
I didn't get you. Please repeat again.
Is it a linear pair?
Linear pair means? linear shape
Like
you want to
straight
say?
line. Yeah, yeah, like a straight line.
Okay, correct. Now do it for BF3.
It's trigonal planar.
I didn't get you.
Trigonal planar.
Can you repeat it again, please, bit slowly?
Trigonal planar.
Right, that's correct. Both of you are able to get the structures?
Yes, that's not.
Okay. See, if you know all of them, I will just say BeH2. It is linear. How did you get that? Have you been taught about the hybridization also?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay. So I'll quickly go through that. What I wish to tell you is that why do we use the concept of hybridization? Any idea, Shweta and Ananya?
Want to repeat?
Why do we need hybridization?
It is the intermixing of the atomic orbitals of nearby same energy, by the nearby same energy to form a new orbital, like a new
I
hybrid
agree.
orbital.
I completely agree. Your definition is correct, Ananya. But the thing is, why do we need hybridization? Let me explain it to you. Like methane is a very familiar compound, right? Atomic number of carbon is 6. We write its configuration as 1s2, 2s2, 2p2. This is the ground state. I write it as GS, or ground state configuration of carbon. Looking at it, it appears that it will have only 2 bonds. But in the bonding, only the valence shell electron participate. So I'm telling you how to find the hybridization with the reason. We have to, you might be taught, I agree, but I want to repeat it so that you do not make any mistakes. For finding the hybridization, we have to draw all orbitals of valence shell, even if empty. Right? So, second is the valence shell that we understand. So, what we will do? We will draw 2s and we will draw 2p. We will have 2s2 and 2p2 will be drawn like this. But we have to draw the structure of CH4. Therefore, we say it will have a excited state. That is, at the time of reaction, when the atoms collide with each other, what happens? that some of the electron gains certain amount of energy and move to the next higher orbital. So what happens? The 2s electron gets unpaired and we get this type of structure, right? Now this is, you may think that it can have any other configuration also, but that is not done here, because if it has to form a bond, it will have to show, or it will have to have this type of a configuration there. So what it does is, now, why do we need hybridization? Now, you have heard or read some of the reactions of methane in class 10th. Let's say we say methane undergoes oxidation to give you CO2 and water. In this case, you can see all the four bonds of methane are broken up, right? So have you ever, you know the structure of methane? We draw it like this. For the simplicity, you might have drawn like this. Every free ending is hydrogen atom in both the cases, right? Has anybody told you to break only one bond like this or this one? No. Every time we say break any bond first or break any of the bond, that means all the bonds are of equal energy. But if you recall your above, what you understand between 2s and 2p, which has more energy? Please tell me. 2s and 2p, which is having higher energy. Shweta, which is having higher energy? 2s and 2s or 2p?
2p orbital.
2p orbital, correct? So that means these three in methane, these three CH bonds should be more energetic and this should be less energetic, isn't it? Is it making sense to both of you?
Yes, ma'am.
Okay, to resolve this issue, the scientists said we will pool up the energy, whatever energy they have. Let's say it was having 20 joules of energy. They were having, let's say, 30 joules of energy each. So they say they pool this one. So this will make it as 20 plus 30, 30, 30. So that will be 110 divided by 4, right? So that means you will have 4 orbitals of equal energy. So either Shweta or Ananya was telling me the correct definition of hybridization. That it is the amount of energy which is redistributed. What we do, the orbitals of almost equal energy redistribute their energy so as to form new orbitals of equal energy, right? The orbitals are named after the name of the participating orbitals. In this case, 1s and 3p orbitals are participating. So this one is referred as sp3 hybridization. Is it clear to all of you?
Yes, ma'am.
Okay. So coming back to BeCl2, what is its structure? You said it is linear. Bond angle is 120 degree. We draw it like this. I hope you know how to draw this one. Is it clear? Oh, sorry, not 120, it is 180. Is it clear to both of you? So that, see, I will teach you quickly if you know it already. We have to do a lot of things. We will complete the other things then. I'll tell you what is the geometry which I was talking about. There are 2 points. 2 points at maximum distance. The bond angle has to be 180 degree and it has to be linear. 3 points in the same plane. So what they will do? They will form, importantly, this one is called as trigonal planar. When all 3 points are in same plane and this bond angle is 120 degree. When you talk about 4 electron pairs, then you say that will be tetrahedral. And bond angle is 109.28, right? What about the 5 electron pairs? Do you know what will be the geometry and the shape?
Trigonal bipyramidal.
Correct, trigonal bipyramidal. Similarly, for 6 electrons, right? That shape will be
Octahedral.
octahedral, correct. So good that you already know about that part. But if we have a question like this, like methane, ammonia, and water, do they have the same bond angles? Do they have the same geometries? If not, why? Any idea, Ananya?
Mom, they don't have the same shape.
Why? See, again, this is an important 3-mark question.
Like the repulsion in the pairs is like more, so the angles will change. It will differ.
Okay. See, let us spend 2-3 minutes in understanding what you will write and how you will write. I have just gone through some of the papers which some of you have given last week the paper of structure of atom. Yes or no? So I'll appreciate if we can spend some time, not me, you. You should spend some time in writing the answers because you will be evaluated only on your writing skills, right? We say in case of methane, ammonia, and water, both of them have, all 3 of them have 4 electron pairs. As Ananya correctly said, what we have to write, out of 4 electron pairs, methane has 4 bond pair electrons. This has got 3 bond pair and 1 lone pair electron. Water has got 2 bond pair and 2 lone pair of electrons, right? Then you have to write, you can draw only this much simplified structure and then say that again, the famous line which we have learned or both of you know, that lone pair repulsion. See, write the complete sentence. Teacher will not understand unless or until you write the complete sentence. Lone pair repulsion is highest, followed by lone pair bond pair repulsion, followed by bond pair repulsion, right? So I believe your teacher must have told you that in case of, if I try to draw ammonia, since it has got 4 pair, I will think it to be like this. one position being occupied by lone pair and other three are bond pair, right? This is lone pair and this is bond pair. This repulsion is high, right? I will write high repulsion. Here also it will be high repulsion. As a result, the bond angle is what? This H N H. This H and H bond angle will squeeze down because angle around a point is of only 360. And lone pair will occupy more space. As a result, bond pair will squeeze down. As a result, this will become less than 109.28, which is a bond pair. All four bond pair, the bond angle is 109.28. In case of ammonia, it becomes approximately 107. Now, if I talk about water, water has got two lone pair of electrons and two bond pair of electrons. See, lone pair will occupy the maximum position. They will be far apart, right? Because repulsion is highest. So bond angle will further the NaOH bond. Please remember, that's how we count bond. HOH bond. It will reduce to approximately 105. In some books or in some references, it can be even as 104.5 degree also. It's a general estimation for one lone pair. Decreases bond angle by 2.5 degree. You can note it down. It may be an important information. Do you know it beforehand or not? Ananya and Shweta, do you know this fact?
No, ma'am.
Okay, please note down. It's important. It's again approximately, not always. 109.28 to 107. 107 to 105 degree or 104.5 degree. Is this clear to all of you?
Yes.
Okay, note it down. Should I move ahead? Okay. So these are the examples. If you wish, you can note down. Else, they are always in your books. Now, based on these, I just want to make one more point very clear or show you how the chapters of chemical bonding and periodic classification are related to each other. Deliberately, I have put this example. BeF2 and BeCl2. If you remember, fluorine and chlorine belong to the same group. So they will show the same type of a structure, right? Similarly, magnesium fluoride and magnesium chloride. They will show same type of a structure. Clear? Moving to the next example. BF3, BCl3, again, boron and aluminum belong to same group. Chlorine and fluorine belong to the same group. So they are bound to have the same geometry. Now you can see the heading. We are talking about the geometry of molecules in which the central atom has no lone pair. We are talking all bond pair. When you have three bond pair, it has to be triangular planar. Bond angle has to be 120 degree. For 4, it can be written as 109.28. or 109.5. Both of them are correct. Then for 5, as you know, it is triangular bipyramidal. Triangle is in one plane, that is this plane, and the two bonds. One is above the plane of molecule and other is below the plane of molecule, right? Instead of this representation, we can probably draw it like this also, that we have PCl3, right? So these bond angles are of 120 degree, and this is triangular. And rest of the two bonds are perpendicular plane way. This and this. These are 3 chlorines, right? Do you know what is these 2 chlorine bonds are called as? And then the 3 chlorine bonds are, you can see in the image, all the 5 bonds are not equal. 3 bonds are of different bond length and 2 bonds are of different bond length. Do you know what is their names? Or they do not have any different name? Shweta, do you have any idea? Okay. I'll get back to it in a moment when we talk about SF4. There it will be more clear. Here we have octahedral, right? Bond angle is of 90 degree. Although you cannot see them in a 2D, in 3D, this is a visualization where you can see. Then this we have already discussed, that lone pair repulsion is more. Therefore, the compounds which have at least one lone pair, they are said to be having distorted geometry. And if somebody is having, or some molecule is having all bond pair electrons, they are referred to as having a regular geometry. So there are 2 terminologies. If, like for methane, I will say methane has a regular geometry, but ammonia and water have distorted geometries. They do not have a regular geometry, right? Now this I have tried to capture it. I'm not too sure whether it is there in your NCERT books or your books or not. If here L represents a lone pair. They are having this particular molecule AB2L. It is having 2 bond pair and 1 lone pair. L is for lone pair and B is the bond pair, right? It has got 2 bond pair and 1 lone pair. So it will be having a bent structure. If you do not remember the structure of the distorted geometry compounds or the compound having a lone pair, you can always say, instead of bent, if you don't remember bent, you can always say it is having a distorted geometry, right? Instead of not writing anything, it's better to put it as distorted geometry. Are you aware of this section of the bonding, Shweta and Ananya?
Yes.
Yes or no? I didn't get you. Please be louder.
Yes, ma'am.
Okay. Ammonia, trigonal. So I'll just quickly go through this if you know them. Ammonia will have trigonal pyramidal. Water will have again a bent type of a structure. Then if somebody is having a 4 bond pair and 1 lone pair, it will be having a seesaw structure. Then ClF3, you can see it is having a T-shaped. CLF3 is often asked, what is its geometry? What's its shape, right? If you remember it well, fine. If not, then please note down and remember it. Then talking about AB5, they will have a square pyramidal geometry. Then XCF4, which are having two lone pair, they will have a square planar geometry, right? Now just do this question. How many lone pair of electrons are present in xenon? Probably the position of xenon in periodic table will help you in finding the answer. Any answer, Shweta and Ananya?
Can you tell the atomic number of xenon?
That even I don't know. Have you learned your periodic table vertically? I can give you a hint. It is a zero group element or group 18 element. In group 18, we have neon, argon, krypton, xenon. I believe it should help you. Whatever is the configuration of neon in valence shell, same will be applicable to xenon also.
It's option B, 2 and 4.
Option 2 and 4. Who's that? Who said that? Ananya or Shweta?
And
Okay, correct answer. See, the moment I see XCF4, even if I don't remember where it is placed, what clicks me? There are 4 bonds between xenon and fluorine. That means option B, even if I don't remember, I don't know, it has to be the correct answer. It is going to form 4 bonds. So 4 bond pair, right? And I again remind you, students, please recall, remember, or what you call it as mug it, remember it, do whatever. You have to know your periodic table that way only, right? So that means it is clear. Xenon has 4 bond pairs and 2 lone pairs are still there. Now, here, as you were saying that you are clear about it, let's understand this. This is the structure of SF4, right? Sulfur tetrafluoride. I have drawn 2 structure for it. Sulfur, like oxygen, has 6 electrons in its valence shell. As you can see, it has formed 4 bonds. SF4 means there are 4 bonds, right? And then it has 1 lone pair. Now tell me, the name of a structure is given to you, it is seesaw. I want you to make a choice between structure A and structure B with the reason. This is again one of the most important questions being frequently asked. What's your answer, Shweta?
It's an option B.
Option B. Why?
Sure.
I'm not able to hear you properly, Shweta.
Not
Can you
sure,
read it?
ma'am. I'm not sure.
Okay, that's a guess. So Ananya can safely say A. Either of you must be correct, right? So let's resolve this issue. This is important. See, I'm very happy that you are very clear about the basic concepts of hybridization. But the question asked will be of certain exceptional levels. So let us prepare for that by understanding this. If you look at, this is what I have taken up from NCERT, and I believe they are supposed to ask this type of a question. Earlier, the format of question must have been different, but with NEP, the format of the question has changed. They have become more pictorial. So they have given you two options. Which one is correct and which one is not correct. See, in this position, they say this position, as you understand, this is called as axial, where the lone pair is placed in the first image. This one, see, I said to you when we were drawing PCL 5, I said I will just explain to you which one is axial and which one is equatorial, right? As you can, equatorial position, these positions, the perpendicular positions are known as axial, right? So the two bonds which are making an angle of 90° with phosphorus, if I can draw only these two, phosphorus and chlorine, right? These are called as equatorial positions, rather, sorry, axial positions, right? The other one is axial and one is equatorial. Lone pair is present in axial, right? That means what we have to remember, axis means which is present at 90°. So for axial, we can say 90°, right? So this bond is of 90°. So they are trying to say the lone pair is present in axial position. So there are three lone pair bond pair repulsion. That is the first repulsion is with this fluorine. There are three fluorine and bond pairs. Let me choose another color. This one is one interaction. This is second interaction, and this one is the third interaction with bond pair electrons, right? So what they are saying, in image number A, lone pair is present in axial position. So there are three lone pair bond pair interaction, right? This one is your lone pair. It will be interacting with 1, 2, and 3. But if it is present in equatorial position, to remember equatorial, we can always assume it as something at equator, right? Equator has to be in the center of the earth. So equatorial means in the middle of the molecule. If the lone pair is present as in equatorial position, as in case B, there are two lone pair bond pair repulsions, right? It will interact with this and it will interact with this only, right? Lesser the number of lone pair bond pair repulsion, more will be the stability. So the correct option is B. The correct image of SF4 will be the second one. Till now, they were asking the question in the form of draw the structure and shape of predict the hybridization and shape of SF4 molecule. That was a pretty straightforward question. You could always remember and reply it. But if they give you 2, they may give you 3 or 4 more options like this. So what you have to remember, that there can be 2 positions for bonds. One is called as axial and one is called as equatorial. Equatorial is at equator. It will be in the center of molecule, right? Axial is at 90 degree. So now the rest of the things can be concluded. If it is at a axial position, it is bound to interact with 3 bond pair of electrons of fluorine. But if it is at equatorial position, it will interact only with 2 bond pair. So lone pair, bond pair repulsions will only be at 2 places. Hence less repulsion, more stability. Is it making sense to both of you?
Yes.
Yes or no?
Yes.
Okay, you want to note it down or done?
1 minute.
Okay. Done?
Done.
Okay. Now talking about merits and demerits, I'll appreciate if you can go through NCERT and find at least 3 points. Put it in your words, right? And what are the merits and what are the demerits of VSCPR? You must do them, right? So it helps you, as I have just taken it from NCERT, the 3 most easiest points you should remember and say, it tells you how to find a structure or the shape of the molecule. Don't need to mug all the structures, right? Then the second point, which I made it clear with this example, that only valence shell configuration is important. How many electrons, like sodium chloride will have ionic structure like potassium chloride, right? BF3, BCl3, BBr3, all are going to have the same structure. That's what they are trying to tell you in the second point, that only electronic configuration is required to draw the shape of the molecule. Electronic configuration, we can always put it more precise, only outer shell electronic configuration, right? Total number of valence shell electrons can predict the geometry of the molecule. Again, no need to know all the things, right? Out of the demerits, that for isoelectronic species, you cannot find their shapes, right? Then IF7 structure, there is a discrepancy. You need not go into the details. You just need to understand that IF7, the structure given by VSCPR and by X-ray diffractions are different, right? Then it is not able to explain the structure of transition metal compounds. Transition metal compounds will be taking up in the next year. There we have 2 separate theories, like one of them is CFT, crystal field splitting theory, right? With the help of these other theories, we are able to explain the structure of the compound. So the drawback you must remember is that it does not explain the structures or the shapes of the molecules of transition metals, right? And the most important one is it does not predict the magnetic character. Magnetic character means whether something will be paramagnetic or non-magnetic, paramagnetic, or diamagnetic in the magnetic field. Do you know about what is the magnetic character? Do you have any basic idea about it? Okay, we say that if if you say that say if I am wearing these bangles, one of them may be metallic, made up of iron. So what you have to do? You have to bring a iron near to these bangles. If any one of them is attracted towards it, that means it is made up of iron. Similarly, the compounds, if they are allowed to move in magnetic field or magnetic field is applied around them, if they show movement, they can be considered as paramagnetic. If they do not, they are called as diamagnetic. Again, the details are in class 12th only. So you must remember that one of the biggest drawbacks is that it cannot predict the shape of d block compounds of d block elements. Number two, it cannot predict the magnetic behavior of the compounds, right? So this was the question which we have discussed. See, I have kept this slide to make you understand, right? The same question for SF4 molecule can be put in this complicated manner also, right? Is it clear, Ananya and Shweta?
Yes.
Okay. You have to write the same answer. That lone pair, bond pair is less in this case, so more stability. So this structure is correct, right? Do you still want to copy it down, or you will be able to do it at your own?
And we'll do it after.
Okay, moving on. Yeah. You can take this one as for your homework, because discussing the same will take some time. Please note it down that you have to predict the structure of these or shapes of these molecules. SiF4, NH2 minus 1, NH4 plus C2H2. Some of you, the only purpose of giving it to you is that you should be able to apply the concepts which are being taught to you. You can leave C2H2, note it down, note C2H2. We'll discuss it when we talk about the sigma and pi bonds. Have you done the sigma pi bond concept also?
Yes, we will do that.
Okay, now just give me one answer so that we can still plan a very quick ending to this chapter. That in acid, the C2H2 is acetylene, right? How many pi bonds does it have? Or what type of hybridization acetylene have? Is my question clear to both of you? We have C2H6, we have C2H4, and we have C2H2, right? All of them are the compounds of carbon. Both of them have 2 carbon each, in fact. What is the hybridization? Shape and number of sigma and pi bonds. Are you getting my question, all of you?
Yes, ma'am.
Okay. So, beginning with you, Shweta. Is there any issue in answering this question? Ananya, what will be your reply, or if you are finding it bit difficult or off topic, you please share it with me.
The shape for C2H6 is tetrahedral.
Please be a bit louder. I'm not able to understand you.
The shape for C2H6 is tetrahedral. Shape.
Okay. Then are you clear about the sigma concept of a sigma and pi bond? Where are they formed?
Yes, ma'am.
Okay. What about
Pi
you,
bond is
Shweta?
zero.
Yeah. Please speak, Ananya.
Pi bond is 0.
Okay. In first case, pi is 0.
You should define sigma bond as well.
How many sigma? For C2H6, you said it is tetrahedral.
0 pi bond.
I didn't get you.
Ma'am, I said 0 pi bond.
Okay, correct. You said 4 sigma, 4 sigma, 0 pi. Correct. Moving to C2H4. Shweta, are you able to recall and do something for this particular compound?
Ma'am, are there 5 sigma bonds?
Ma'am, for this, the shape is trigonal planar. C2H4.
Okay.
And 1 pi bond.
You said 5 sigma, 1 pi. And what about C2H2? Okay, I'll give you this one as homework because see, please, if you wish, you can recall and go through your sigma pi bond concepts. We'll take it from here because there is no point in spending some more time into it. I felt you know this, so I believe there are certain gaps which we need to fill up, right? So you will take these compounds. Even if you have seen the answer, I wish you to solve them. SiF4, NH2 minus, NH4 plus, and the 3 carbon compounds, not only C2H2. I'm adding adding C2H4 and C2H6 to it also. And there you have to find out the sigma and pi bonds also. Clear? Please note it down. We will begin the next class with this. Okay, now we will be talking about something about the bond parameters. Bond parameters, we will complete at least 4 because we have done most of them already. And then we will have a reality check on resonance. What is a bond length, which we have, this we have done in earlier class also when we were doing the periodic classification. We have understood covalent bond, that van der Waals radii as well as the ionic radii. Do you remember that? Just for help you out to have a proper definition, which may again be asked in the exam, that bond length is defined as the equilibrium distance. Equilibrium distance, why we have introduced this new term, equilibrium distance, here is that we now understand that electrons are cloud, right? Equilibrium distance, that is when the atoms are at maximum distance. So therefore, it is important to use the word equilibrium distance. Yeah.
Mom, we actually have a math exam tomorrow. And
So can you please excuse us and finish the class today?
Okay, we'll take it up in the next class, but just let me help in understanding. Are you clear about the concept of this, what do I say, resonance? Are you clear about it?
no, Mom, we haven't learned that.
Okay, bond order, you have done it?
Yes,
Yes.
Okay, so we'll take it up accordingly. And by Wednesday, you will be able to do the homework or not?
Yes, ma'am, we will be.
yes, Mom.
Okay. Okay, so let's end the class at this note. We will take up from where we are leaving today, right? All the
Thank
best for your maths exams.
Thank
Thank
you.
Welcome.